Now with our Arduino project, we're going to be using a motor controller. The reason why we're using a motor controller is because the Arduino does not have an output or high enough current output on the pins to actually drive a motor. So we need some switches, internal switches, that will actually do it for us. If we do hook it up directly to the Arduino, the current draw will be too large and you're risking burning out the internal mechanisms of the Arduino. So we're using this to save our Arduino from burning out and releasing some magic smoke. So this is the motor controller that you'll be using. It actually has the capability to control two motors, as you can see here, motor A and motor B. The inputs in 1 and in 2 will actually control motor A, and in 3 and in 4 will control motor B. So this is the circuitry that's inside of here, and there's actually two of them. Now we're going to hook this device up to power, so VCC, and also to the negative, and I'll show you that on the circuit board soon. However, there are 4 switches. These 2 switches are connected, so if you activate it by using in 1, by sending a high to it, they will close. If I activate it using in 2, these 2 will close. Now, what does that allow us to do? Well, it actually allows us to make the motor go forwards and backwards by supplying 2 inputs. So if I look at scenario 1 down here, if I have a high on, or a 1, digital 1 or a high on input A, that will close this switch and this switch, and the current will flow to ground that way, and the motor will spin in that direction. If I then open that, send it to a 0 and put a higher over here, then the switch B will be closed and it will actually flow this path, which is sending the current in the opposite direction, and that will actually make the motor spin in the reverse direction. So if you have a remote control car going forwards and backwards, you can actually control the inputs. So if you have a high here, it will go forward. If you put a high on this one, it will actually go backwards. So if we look at our code here, we've actually got pin mode 5 and 6. We're going to put them as outputs. And there's a reason why we want to use those pins, because we can actually control the speed, because they're actually pulse width modulated outputs possible on those. Now we're going to do 5 and 6 as output. So if I want it to go forward, I'm going to send a high to pin 5, and that is going to be connected to the input 1 on the actual board. If I then hook up pin 6 to input 2, all I need to do now is send a high to pin 5, make it go forward, wait 3 seconds, and then I want to stop it. Now I want it to go backwards, so now I put a high on pin 6, which will be going into input 2 on the board, and wait 3 seconds and then stop it. Now, because I'm using pins 5 and 6, I can actually make it go half the speed. So maximum value is 255. So if I set it to something like 128, then on a pulse width modulated pin, or a PWM, I can actually do analog write, an analog value, and that will actually pulse the motor so it only spins at half the speed. All right. Now, you can't set things like 10 or 15, because the pulses are so short and small that the motor just doesn't have time to react to them. So you'll need to do some experimentation to find out what is your minimum value that you can achieve with your particular motor. Usually the smaller the motor, the lower the number you can get. The higher the capacity motor, then less likely that's going to occur unless you add in a few extra components. Alright, so let's go and have a look at this in action.